Hello everyone. So in today's video, we are going to solve this longest repeating character replacement problem. So we are given a string as, and so we are allowed to do a replacement in this given string for key number of times, and we need to return the longest repeating character after the replacement. So for example, we are given an string, and then the time number of times we are allowed to substitute. And if we take a string, which is a window of string in this case, we have to return a substring length when perform this many times of substitution has the longest repeating character. So if we simply take this, right? Take this is we have a window of a string given to us, and then we are looking at the portion of a string. And if we are allowed to do one time substitution, meaning if we change this b to a, we have our valid answer, and the length of this is what we need to return as our answer. So this is what the question is asking us. And so as you can see, we are operating on the window of a string, and we are doing some kind of validation on the substring of a string. So basically we are trying sliding the window to find our valid window, and then we will basically returning the length of that valid window. So since I'm using the word window, it rings a bell that this can be solved using a sliding window technique. And what's the basic framework for a sliding window technique? It's basically you have a start, and then you have an end. Initialize, let's say at 0 at this time, where the window literally does not exist. So we initialize two pointer at the same place, and then we say while the end is less than the given ashtart length, then we operate our window on this bigger window. So we have this sliding window. We slide across different portion of the given input, and if something happens, we expand the window, else we shrink the window. So this is the basic wireframe for our sliding window problem. But this obviously does not solve our given question, because it's a little different. We have to deal with repeating character, right? And so we'll definitely use a sliding window technique, but we'll create a different variation of it. And now we see a basic pattern how we are going to write our code. Now let's make additional note what else we need to include in this variation. So we are dealing with first of all, we are dealing with longest repeating character. In this case, let's say our max result, right? Maximum repeating character. And another is we are dealing with repeating character, which is basically we have to address the character, right? We have to address the character. And let's just think about it. How can we find the length of a valid window? Basically, how did we come across this substring, which ultimately lead us to our answer? The answer is we have to have, like, this is what I think, right? This is what I have as a formula. So you have a given window. The length of this given window is 4. So this is how you can derive it. Basically, you have a window, right? For example, if you have a window of 5, 4 in this our valid solution, we have a window of 5, and what we do, we reduce the maximum frequency of the most repeating character, which is a, that is now 3, right? We are left with answer 1 and c. So we have the character that is not repeating is only 1, and we are allowed to do a substitution of times 1. So if we replace this b with a, then we have our valid answer. And all the answer that does not follow this principle, that's this formula, which is total size of sliding window minus the maximum frequency of the repeating character in that window. So this gives us a number, and that is, let's say, our okay, let's just say it as a number. And anytime if this number is greater than what we are allowed to do a replacement, then we know that in this time we have a invalid solution. So in this time we have an invalid solution, right? And what can we do if our window is invalid? Uh, we have to cut the part where it becomes invalid. So that means we have to shrink it. If we expand it with the invalid window, we definitely know that it's not going to work. So we have to cut our window. That is basically we have to shrink our window. And basically we need to deal with some kind of invalid window. What do we do in times of invalid solution? So basically take care of our invalid window case. And 4 is basically we just need to return the size of the valid window. If we have a valid window, we just need to return the valid size of the valid window, because in this case what did we do? We simply return the size of the valid window. So we have this basic algorithm for sliding window, and we need this kind of variation to be addressed to solve this problem. So how can we do it? So let's start. So we'll say we will. So I'm not thinking much. I'm just simply using my basic sliding window architectures. That is start and end with equals to 0. And then we also need this kind of since we are dealing with longest repeating character, that is we are storing our result in the max result. And here in order to find our answer, what did we do? In order to find our answer, we have to have some kind of mechanism that tracks the maximum frequency um, number in the current window. So we say we need some kind of frequency map, right? Let's say we use an object this time, and let's just start our answer from here. So while our end is less than the astronaut length, then what do we do? So what do we do with the first character? We first need to address the character. Since we are looking for the repeating character, we need to address the current character. So we put it on our frequency map, and then current character is given by the index end, since we are operating on the end. And um, so what do we say? We say we basically if we have never seen it before, we put it the value of 1. If we have seen it, then we add it to the previously seen value, right? So for it, that simply means if we are dealing with this string for the first time a, we say a equals to 1, and the second time we see another a like this, then we say this 1 becomes 2, right? Similarly, this is what we're going to do here. So if we seen it for the first time, that means if frequency map as at n does not exist, you take 0, right? You take 0. If this does not exist, you take 0. If this exists, you just add it 1. So we updated our frequency map. For this answer, what did we do? So here we need to have some kind of frequency. We just not need to record it, but we also need to use what we have recorded, right? We need to deal with the frequency to find the valid window. So this is what I'm gonna do now. Let's say my constant. What is this? Max frequency in current window is what is given by the value we stored in this frequency. So this gives us that. To find out if the current window is valid or not, we need to store it somewhere else, right? Because in every iteration we are going to initialize it again, and so that does not make sense. This as a let, and then initialize it to 0 at the first, and then now when we use it again, then this is what we're going to do. We say either take it from the current frequency if you find it to be max, uh, either the current frequency that is already stored, current window, no, not the current window, actually third so far. Maybe this is a good name. Maximum frequency encountered so far is either the maximum so far or the new value after update, and maybe this is what can help us find the maximum frequency encountered so far. For example, in this case of this example, maybe we have a equals to 3 from here. And now let's say what, like we know that how to find our answer, right? If our window is valid, then our max result is simply going to be the map.max of max result, or the size of the current valid window if the window is valid. So that is given by n minus start plus 1, with n and start both being inclusive to the answer. Uh, but this only applies if the window is valid. What happens if the window is invalid? So, and what is the condition when our window is invalid? If the number, if the non-repeating character in the sliding window is if the non-repeating character in the sliding window is greater than uh, the substitution allowed, then we know our solution is valid. So how do we write it in the formula? If something is greater than k, so what is that something? Something is basically the sliding window length minus the maximum frequency of the repeating character, right? So if a sliding window is given by n minus start plus 1 minus minus the maximum frequency encountered so far. If this is greater than the value of k, if this is greater than the value of k, then we know that we have an invalid window at this case. And the only way we can make a window valid, or like cut the invalid part, is through shrinking the window. So we need to do our start. We need to basically move our start to further right to shrink the window. But we also need to get rid of what we stored in the frequency map. So frequency map at start. Now this becomes as at the start becomes minus the minus 1. Yeah, so this is what we need to do, and this now process with all the invalid window, and then once the window is valid, then we again start calculating storing the maximum result, and in the end we need to return the max result. Now let's see if this works. Oh, and then when does this end increases, right? We also need to write that logic. So we need to say n plus plus. Okay, nice, this works. And another maybe simple tweak you can make is, since the end increases no matter what, we might also want to use for loop instead of the while loop, since there's no specific condition where we need to increment the end. So that's another maybe improvement we can do on this algorithm. And let's discuss about the complexity. Time complexity is basically we are iterating all the way through the length of this given length. So at the worst case, it's gonna be the O of n being the length of the s uh, input, and the space complexity is basically we are initializing a frequency map, and in the worst case, every character can be a new character, so that also becomes the O of n being the length of the input string.